Hello, hello. Welcome to all the students. I am Captain Rail Sanju. Welcome to online classes from Department of Chemistry, Government Degree College, Peddapalli. In the yesterday class, we completed the introduction of carbonyl compounds and the preparations of carbonyl function group that may be aldehydes and ketones. Today we are going to learn about reactivity of carbonyl function. In this reactivity, the electrophilicity of a carbonyl group derives from resonance effects as well as inductive effect. Here, based on resonance effect, thus that particular carbonyl function group, pi bond cleavage takes place. In that case, oxygen gets negative charge, carbon atom gets positive charge. Based on resonance effect, we can explain these resonance structures. In inductive effect, based on inductive effect, in between carbonyl, in this carbonyl function group, carbon and oxygen, pi bond 100 electrons attracts by highly electronegative atom of oxygen. In that case, oxygen atom gets delta negative, carbon atom gets delta positive. Based on these two effects, resonance and inductive effect, hmm, uh, these resonance structures we observe, uh, what happened in the reactivity we'll discuss in the next slide. Here, this is about resonance and inductive effect clear information for how the electron density on the oxygen and carbon atom will discuss now. On the resonance structures, one of the resonance structures exhibits a positive charge on the carbon atom, indicating that the carbon atom is deficient in density. Electron density. Here, based on resonance effect, in this second structure, the carbon atom is electron deficient because it has a positive charge. Uh, when we go to inductive effects also render the carbon atom deficient in electron density. Based on inductive effect, uh, here also where we understood the carbon atom delta positive, it indicates the carbon atom is deficient in electron density based on the inductive effect. Is it clear? Ah, as a result, this carbon is particularly electrophilic and is susceptible to attack by a nucleophile. In these two cases, based on these two cases, resonance effect and inductive effect, the carbon atom, carbonyl carbon atom, it has a positive charge. In that case, the nucleophile attacks very easily on that particular carbonyl carbon. Is it clear? Is it clear? Generally, this carbonyl carbon undergoes uh, nucleophile. Nucleophile easily attacks on this particular carbonyl carbon. Okay, is it clear, all of you? How the nucleophile uh, attacks on this particular carbonyl carbon. I will discuss clearly. Generally, nucleophile attacks on carbonyl carbon, hmm, approximately 107 degrees. How it is here? Here, this carbonyl carbon, two alkyl groups and carbonyl C double bond O. These carbonyl function group arranged in a planar manner. Here we are representing with a blue color shade. Planar manner. This is a planar manner, trigonal planar structure. In this planar manner trigonal structure, here attacking of nucleophile. Please observe the molecular orbital calculations suggest that nucleophilic attack occurs at the angle of approximately 107 degrees to the plane of the carbonyl group. To the plane of the carbonyl group. This is the carbonyl group is arranged in a planar manner. In this planar manner, nucleophile attacks 107 degrees angle. Here, the carbonyl function groups are two alkyl groups and C double bond O. Generally, this carbon undergoes sp2 hybridization. Based on this sp2 hybridized orbital, the structure is trigonal planar. Trigonal planar. After attacking of this nucleophile negative charged species to forms this the center of the carbon bonded with four groups nucleophile and two alkyl groups and oxygen. This center of the carbon undergoes sp3 hybridization. As a result, it gives tetrahedral structure. This formation of alkoxide ion. This is a alkoxide ion. This alkoxide ion structure is a tetrahedral structure. Tetrahedral structure. Alkoxide ion. The center of the carbon undergoes sp3 hybridization. Is it clear? sp3 hybridization, alkoxide ion is produced in this uh, after attacking of nucleophile. Is it clear, all of you? Uh, uh, 107 degrees to the plane of the carbonyl group. And in the process, the hybridization state of the carbon atom changes. We observed that. Generally, that ketonic function group sp2 hybridized carbon. This carbon hybridization sp2 hybridization to it changes as a sp3 hybridized orbital. Automatically the structure is also changed. In the first case, in the carbonyl function group, it contains, it exhibits trigonal planar structure. After changing of this hybridization state, it converted into tetrahedral structure. Tetrahedral structure. Is it clear? Is it clear, all of you? This is about um, change of hybridization state, sp2 hybridization to sp3 hybridization. In that case, automatically the structure is also changed to forms alkoxide ion tetrahedral structure. Now let us go to that clear information over how the alkoxide ion structure exhibits. Here, The carbon atom is originally sp2 hybridized. Just now we discussed. Actually, in aldehydic or ketonic function group, the carbon atom, carbonyl carbon, originally hybridized sp2 with a trigonal planar geometry. This type of structure, after the attack, the carbon atom is sp3 hybridized with a tetrahedral geometry. This is the tetrahedral geometry structure. Okay, generally that sp2 hybridized state 2, sp3 hybridized state is changed, and automatically structure is also converted as tetrahedral form. Okay. Hmm. In the recognition of this geometric change, the resulting alkoxide ion is often called a tetrahedral intermediate. This is called as intermediate, tetrahedral intermediate alkoxide ion. It is a unstable ion, alkoxide ion. It converted into alcohols immediately after transfer of hydrogen. We'll discuss later. This is the unstable alkoxide ion intermediate is formed in this reaction. Okay, is it clear, all of you? Okay, students. Okay. Ah, now we'll go to discuss about aldehydes and ketones comparison. Here, ketone. In a ketone, two alkyl groups are present. Two alkyl groups attached to carbonyl carbon. But when we go to aldehydes, here that carbonyl carbon is attached to only one alkyl group. The remaining is hydrogen atom. A ketone has two electron donating alkyl groups that stabilize the partial positive charge. Partial positive charge. Here, an aldehyde has only one electron donating alkyl group that stabilizes the partial positive charge. Okay, generally we'll discuss clearly based on this positive charge in aldehydes and ketones, carbonyl carbon positive charge, which one is more stable, which one is less stable, and we will also discuss the reactivity of that particular carbonyl carbon. Here, the delta positive charge of an aldehyde is less stabilized than ketone. Here, it is less stabilized because it attached with only one alkyl group, one electron donating group, only one side. In that case, it is a less stable compound. It undergoes reactions very fastly because more reactive, this aldehyde, when compared with the ketone. Ketone. Is it clear? In ketone, it is more stabilized delta positive carbonyl carbon. What is the reason means this carbonyl carbon is attached with the two alkyl groups. Two alkyl groups, these are two electron donating groups. That is also called as plus I inductive effect. Electron donating groups. Two alkyl groups attached to this particular carbonyl carbon. In that case, it is a more stable compound compared with the aldehyde. Compare with aldehyde. But here an aldehyde is a less stabilized compound than ketone because this aldehydes undergoes reactions very fastly. Fastly. As a result, aldehydes are more electrophilic than ketones and therefore more reactive. More reactive. Is it clear? More reactive. It undergoes reactions very fastly in various types of nucleophilic reactions. It undergoes very fastly. Those reactions we will discuss now in the next slide. Please observe. Please observe in the next slide. Here, aldehydes and ketones react with a wide variety of nucleophiles. Wide variety of nucleophiles. Here we are using on reaction with the Grignard reagent. Here, Grignard reagents are very strong nucleophiles that will attack aldehydes and ketones to produce alcohols. To produce alcohols. Here, um, here aldehydes are ketones. Both are undergoes in this reaction because here we are using strong nucleophile. This Grignard reagent it produces a strong nucleophile. That strong nucleophile attacks on aldehydes and ketones uh, in the same manner. In the same manner, will produce alcohols. Will give alcohols. Okay. Here, please observe. Um, ketone function group. Here, ketone RRCO ketone. This particular ketone on reaction with a Grignard reagent. Here Grignard reagent methyl magnesium bromide. Generally it is represented with a general formula RMGX. RMGX alkyl magnesium halide. RMGX means alkyl magnesium halide. On reaction with this Grignard reagent in presence of water, this ketonic function group is turned as a alcohols. Turned as a alcohols. This alcohol it is a tetrahedral structure. Tetrahedral structure. How the this in between carbon oxygen pi bond, how the cleavage takes place, how the nucleophile attacks on this particular carbonyl carbon, then the result structure sp3 hybridized tetrahedral structure, how is it is formed, we'll discuss in the reaction mechanism part. Okay. It is a single step reaction. Based on this single step reaction, we cannot understand clearly. Uh, because that we will go to mechanism of this particular reaction. Okay, mechanism. Okay, this is the mechanism part of that particular reaction. Here, the reaction between a nucleophile and a carbonyl group under basic condition. Here, this reaction, carbonyl on reaction with the nucleophile in presence of water, under basic condition, how the reaction proceeds and to forms alcohols in what way we'll discuss clearly with a clear cut mechanism. Here please observe. In this reaction part, it contains a two steps reaction. In the first step, it is a nucleophilic attack step. In the second step, it is a proton transfer step. Okay. Ah, First, we will discuss in the first step carbonyl functional group. This is the carbonyl function group. The carbonyl function group is attacked by a nucleophile forming a tetrahedral intermediate. Here, please observe. This particular nucleophile negative charged species attacking on carbonyl carbon. At that time, this in between CO pi bond cleavage takes place. Oxygen atom gets negative and nucleophile attacks on carbonyl carbon. This is the intermediate, unstable intermediate alkoxide ion. Alkoxide ion tetrahedral intermediate is formed after attacking of this nucleophile, strong nucleophile. Okay, strong nucleophile. In the last slide we discussed these are the strong nucleophiles. This methyl nucleophile is produced from this Grignard reagent. Okay. Ah, After formation of this tetrahedral intermediate alkoxide ion, this alkoxide ion absorbs abstract hydrogen atom from water molecule. Proton transfer reaction. This type of reaction, proton transfer reaction, that proton abstract hydrogen from uh, water molecule. Here breakage takes place in between OH and H. Breakage takes place. This particular tetrahedral intermediate is protonated upon treatment with a mild proton source. This water molecule is a mild proton source. From this proton source, the this particular proton transferred to O negative side to forms tetrahedral structure of this alcohol. Is it clear? This type of reaction, nucleophilic uh, attack on this particular reaction under basic condition. This reaction proceeds under basic condition. In this manner, the same type of reaction proceeds under acidic manner. We will discuss now in the next slide. In the next slide, we will discuss acidic manner. Please observe. Acidic condition. Here, in acidic condition, the same two mechanistic steps are observed. Two steps here also, two steps we observed, but in reverse order. Here, please observe. These same two steps are involving in this reaction part. Two steps are involving, but here in the first step it is called as proton transfer step. Okay, in the under acidic condition it is the first step, but in basic condition we observed this proton transfer step is a second step. Okay, it is a reverse order. That proton transfer step we are representing here, it is a first step. in acidic condition. In basic condition we have observed it is a second step. Please remember that this is the clear information in basic and acidic conditions. This information please remember. And in the second step it is a nucleophilic attack step. Nucleophilic attack. Okay. It is a reverse order when compared with the basic condition. Reverse order. That is, the carbonyl group is first protonated and then undergoes a nucleophilic attack. Here, first carbonyl group, first protonated, transfer of hydrogen from acid. It converted as protonated carbonyl group, protonated group as an intermediate. That particular intermediate attacking of nucleophile to forms alcohols. The result compound is same here also. In acidic condition or in basic condition we are getting alcohols, but the procedure, the reaction proceeds in the reaction mechanism part, it is a different. Okay, here once again please observe in the reaction the carbonyl function group is first protonated, rendering even more electrophilic. Even it is more electrophilic, the proton transfer from acid HA, it is a acid proton transfer to forms protonated carbonyl function group as a intermediate. Protonated. On this protonated carbonyl group, nucleophilic attack. The protonated carbonyl group is then attacked by a nucleophile. Nucleophile. Here, nucleophilic attack and automatically breakage of this particular pi bond. Pi bond here loss of electron. In that case, proton transfer stage, the oxygen atom gets positive. Here, attacking of nucleophile, the cleavage of pi bond, this particular oxygen, positive charged species oxygen, gets neutralized. Gets neutralized. Okay, neutralized compound. And finally, we are getting tetrahedral structure of this alcohol. Alcohol tetrahedral structure is formed in this reaction. In these two reactions, what are those? Under basic condition, the reaction proceeds, and under acidic condition, the reaction proceeds to forms alcohol's tetrahedral structure. sp3 hybridized molecule is produced in these two reactions. But the process of the reaction is a different. The process of reaction is a different in these two reactions. Okay, in these two conditions. Is it clear? Is it clear, all of you? Okay. Oh, very interesting. Now let us go to various types of nucleophiles. Nucleophiles with different atoms, different heteroatoms. Here, Here, first type of nucleophile, oxygen atom containing nucleophiles. Oxygen nucleophiles. Here, please observe. Oxygen nucleophile example is water molecule H2O. Oxygen containing nucleophile H2O, water molecule. And the second one, ROH. It is a alcohol. Alcohol. Okay. Alcohol is also oxygen containing nucleophile. Next, H2O2, hydrogen peroxide. Hydrogen peroxide, it is also oxygen containing nucleophile. These three are oxygen containing nucleophiles. Now let us go to sulfur nucleophiles. It is a H2S gas. H2S gas. And next H2S2. It is a peroxide structure. Instead of oxygen, here thioperoxide. Same H2S2. Okay. Now let us go to nitrogen nucleophiles. Nitrogen nucleophiles. Here the first example, please observe, RNH2. RNH2. It is called as primary amine. Primary amine RNH2. It is a nitrogen atom containing nucleophile. Next, R2. R2NH. R2NH. Secondary amine. Secondary amine is also nitrogen nucleophile. Next, hydrogen nucleophile. Hydrogen nucleophile, the very good example is AlH4 minus, aluminum tetrahydride ion. Aluminum tetrahydride ion. Next, BH4 minus, boron tetrahydride ion. These two are hydrogen nucleophiles. Very good examples. Now let us go to carbon nucleophiles. The carbon nucleophiles, just now we discussed in the reaction, the first reaction, just now we discussed with the Grignard reagent. Grignard reagent is the suitable example for carbon nucleophile. Here RMGX, this is a general formula of Grignard reagent, general formula, alkyl magnesium halide. Alkyl, this carbon atom CH3, for example, R is equal to CH3, that CH3C carbon atom gets negative charge, it acted as a nucleophile, carbon nucleophile. The very good example is Grignard reagent. Next, cyanide ion. Cyanide ion carbon nucleophile. This is also another example. Try uh, phenyl phosphonium ion. This is also carbon nucleophile. These are the different types of nucleophiles. Based on these nucleophiles, now we'll go to various reactions of these particular aldehydes and ketones of nucleophilic with the use of nucleophile. Here, next reaction, hydrate formation. Hydrate formation. When an aldehyde or ketone is treated with the water, the carbonyl group can be converted into a hydrate. Hydrate. Here please observe. It may be aldehydic functional group or ketonic function. This in those two CO, carbonyl function group is present, CO, on reaction with water. Water, it may be aldehyde or ketone, converted into hydrate. Two hydroxy groups. Here, breakage of this pi bond, oxygen gets negative. This H plus ion shifted to O minus, converted as OH. This particular OH nucleophile, strong nucleophile, attacks on carbonyl carbon. In that case, to form hydrate ion, hydrate compound. Okay, in this hydrate compound, please observe on the same carbon atom, carbonyl carbon atom, on the same carbon atom, it contains two hydroxy groups. In this case, it is a unstable compound. These two hydroxy groups attached on the same carbon. Immediately from this hydrate structure, here loss of H plus and loss of OH minus. Finally, loss of water molecule to forms carbonyl function. Because we are representing the reaction is reversible reaction. Reversible reaction. This hydrate is a unstable structure. Immediately it turns as a carbonyl function group. Carbonyl function group. Is it clear? Is it clear, all of you? Hydrate formation. It is a reversible reaction. Ah, the position of equilibrium generally favors the carbonyl group rather than the hydrate, except in case of very simple aldehydes such as formaldehyde. Generally, all carbonyl groups, functional groups that a hydrate formation is um, generally not favors, because this carbonyl, for example, in ketone, acetone, it is a, we are representing 99 percentage, 0.9 percentage acetone. If it is undergoes reaction with the water, it gets hydrate structure. This hydrate is a unstable structure. Immediately loss of H plus and OH minus water molecule. It turns as a immediately 99.9 percentage acetone. Okay, but in case of formaldehyde, in case of formaldehyde, it is a exception case. This formaldehyde, there is no alkyl methyl functional group. Alkyl electron donating groups. Here formaldehyde, the carbonyl carbon is attached with both the hydrogens. There is no alkyl function group. There is no plus I inductive effect groups or electron donating groups, because that this in this formaldehyde, the carbonyl carbon is less stabilized than acetone than acetone. But here the acetone structure is more stabilized structure. If it is undergoes on reaction with the water to form hydrate, this hydrate is an unstable structure. Immediately the reaction proceeds reversible order. Okay, backward reaction. The reaction proceeds in a backward direction. Okay. Here formaldehyde, it is a less stabilized structure. This less stabilized structure on reaction with the water molecule to forms hydrate. Hydrate. This hydrate compared with the formaldehyde, it is more stable because it forms 99.9% hydrate formation. Okay, is it clear, all of you? Is it clear? It is exceptional case in formaldehyde only. What is the reason means in this formaldehyde the carbonyl carbon is attached with two hydrogen atoms. Here there is no electron donating groups. Here, if it is attached with one or two electron donating groups, in that case the stability is increased. Here the stability of formaldehyde is very less because it undergoes reaction. Okay, is it clear, all of you? Is it clear, all of you? In this today's class, is it clear? Uh, and another type of base catalyzed condition reactions and acid catalyzed condition reactions mechanisms we'll discuss tomorrow, because in this short time we cannot cover that mechanism of this particular reactions. We'll discuss tomorrow clearly. Hmm? All the students will meet tomorrow at the same time. Thank you one and all. Okay, students.